Here we're going to use some special triangles to figure out the sine, cosine, and tangent of some basic angles, basically pi over 4, pi over 6, and pi over 3. And we start with a construction here. We draw a square with side length 1, and we cut the square in half with the diagonal. And of course, each of these corners of the square are 90 degrees. So this diagonal bisects these angles, and this angle here has measure 45 degrees, or pi over 4. And now we have a right angle triangle with the angle pi over 4 in it. And so we can calculate its sine, cosine, and tangent. And since both of these sides have length 1, we have the hypotenuse has length the square root of 1 squared plus 1 squared, which is the square root of 2. So now it's pretty simple to see that sine of theta is the opposite over the hypotenuse, so that's 1 over the square root of 2. Cosine pi over 4 is the adjacent over the hypotenuse, that's 1 over the square root of 2. And tangent pi over 4 is the opposite over the adjacent, so that's 1 over 1, which is 1. And we have secant of pi over 4 is 1 over cosine, or the hypotenuse over the adjacent, so that's the square root of 2. Cosecant is 1 over sine, or the hypotenuse over the opposite, so that's the square root of 2. And cotangent is the adjacent over the opposite, or 1 over tangent, so that's 1. So we can now evaluate all of the trig functions on pi over 4. Let's see what we can do with pi over 3 and pi over 6. Well, we start by drawing an equilateral triangle with sides of length 2. And of course these three angles add to 180 degrees, so they each have measure 60 degrees, or pi over 3. So each of these angles are pi over 3. And now from Euclidean geometry, because this is also an isosceles triangle, we know that if we bisect this angle, the line which bisects this upper angle also bisects the base and cuts the base here at 90 degrees. So we have a symmetry here in this triangle. It folds over this line of symmetry. So this bisects the angle, and so this angle is pi over 6. It's 1/2 of the full angle here, which is pi over 3. And now this also bisects the opposite side, which originally had length 2. So the length of this part is 1. And we have the length of the hypotenuse here is 2. And so now we'd like to find the length of this opposite side in order to calculate the sine, cosine, and tangent of pi over 6 and pi over 3. Well, we have, according to Pythagoras, that 2 squared equals 1 squared, let's call this thing x, plus x squared. And so therefore we have x squared equals 4 minus 1, which is 3. X must be the square root of 3. So we have that side is length the square root of 3. So let's focus first on this pi over 6, this angle here. We have sine pi over 6. So for this angle, this is the opposite. The opposite side has length 1, and the hypotenuse has length 2. So this is the opposite over the hypotenuse, which is 1 over 2. Its cosine is the length of the adjacent, which is the square root of 3, over the length of the hypotenuse, so that's the square root of 3 over 2. Its tangent is the opposite over the adjacent, so that's 1 over the square root of 3, or sine over cosine. Secant is 1 over cosine, so that's 2 over the square root of 3. Cosecant of pi over 6 is 1 over sine, so that's 2. And cotangent is 1 over tangent, which is the square root of 3. We can also read off the sine of pi over 3. Pi over 3 is in this corner. Its sine is the opposite over the hypotenuse, so that's the square root of 3 over 2. Its cosine is the adjacent over the hypotenuse, so that's 1 over 2. And its tangent is the opposite over the adjacent, so that's the square root of 3. Secant is 1 over cosine, so that's 2. Cosecant is 1 over sine, so that's 2 over the square root of 3. And its cotangent is 1 over tangent, so that's 1 over the square root of 3.